Okay, so today we're going to be talking about fetal growth restriction. And here's just a light layout of what we're going to be talking about today. So I'm going to go over the purpose, why should we care about it, some background, and then a specific experiment that was done to test the effects of fetal growth restriction on individuals, specifically mice in this experiment. And then we'll go over what they found from the mice they used, and then we'll see what that means for the future. Okay, so basically what fetal growth restriction is, I got this from WebMD. Fetal growth restriction, it was formerly known as intrauterine growth restriction, and it refers to a condition in which an unborn baby is smaller than it should be because it is not growing at a normal rate inside the womb. So this results in a lot of stillbirths. It affects 10% of all pregnancies, which makes it very, very important in today's society. And from this specific study, they found that it affects learning and memory later in life. And this can be caused from multiple different things. The big thing is low protein intake, but it can come from genetics and substance abuse. So basically what happens is there are less neural stem cells, which neural stem cells they're found in our brain. And you can see in this picture to the right, it's just like a little blob, and then it becomes stemmy, as Dr. Miser would say, but it becomes the neuron. So basically what happens in fetal growth restriction is it's making less of these little stemmy blobby things, the thing in blue up to the right. And that means we get less neurons, and less neurons means less cognition. So yeah, and that's a neuron down here in the bottom left corner. All right. And so in their experiment, they used mice, fetus mice, as you can see in the bottom left here, and they put a treatment on them, and it resulted in less cell signaling and less expression of a specific gene. And we'll get into this. But basically, our gene is TET1. So when we overexpress our gene, when we have too much of this specific thing we're studying, that results in less neurogenesis. And neurogenesis is just less of our neural stem cells being created, which we need for our cognition, which is important. So basically when we have too much of our TET1, which is our gene, then we have more notch signaling, and notch signaling is just, I wrote here how we look at the gene, but it's basically just cell communication. So it's our cells talking to each other, which is how we get our cognition. So yeah, in this experiment, as you can see in our little blob, I don't know if you can see this, but I'm going to circle it. Our little circle here, you can see we have less TET1. And so when we have less TET1, that means we have less notch signaling. So we have less cell-to-cell communication in our brain when that happens, specifically in the hippocampus. And that then, in turn, lowers our amount of neural stem cells that are being made. Because our notch signaling controls the amount of basically new neural stem cells that are created, or neural stem cell proliferation. So it lessens the amount of that. And so I wrote here to make it a little simpler. But in my little analogy here, basically when we have less people in a room, let's say, there's less communication, which is fair to say. Less communication results in less thoughts being shared. And here I just have a guy with his head on fire, but it makes you, I guess, dumber in that sense because you have less input from other people. So basically, our person is our gene, our cell signaling, or our communications are cell signaling, our thoughts are our neural stem cells, our neurons, and then our becoming dumber is our lessening of our cognition and therefore our memory as well. So yeah, those are just my sources. But what this implies is basically, it's very important, But through this study that they found with mice, they haven't been able to determine, I guess, the effects on people. So they're just drawing this correlation, but they don't know for sure. But they think this is a fair conclusion to draw. But they want to, I think for the steps in the future, they want to be able to measure the effects that people have behaviorally later in life. Does this really, how is this affecting people? Do they really, have less ability to think and therefore less memories created? Because that's just an unfair way of life that someone has to go through that out of something that's out of their control, just as any diseases are. So I think this is an important topic for us to look at in the future, especially because it's affecting so many, so many of children today. And I'm assuming it'll only go up in the future with the amount of people that are being born every year. But yeah, so that's fetal growth restriction for you. I hope you learned a little something. And I have the journal linked below and some other sources if you want to continue learning. All right, have a great day. Bye.